The P0153 code indicates a slow response from the upstream oxygen sensor on bank 2, sensor 1. This diagnostic trouble code signals that the sensor isn't quickly adjusting to changes in the air-fuel ratio. Bank 2 refers to the engine bank without cylinder 1, typically the passenger side in V-configured engines. Sensor 1 is the upstream oxygen sensor, located before the catalytic converter. The sensor's response time should be under 100 milliseconds. This slow response can negatively impact engine performance and fuel efficiency. Ignoring this code can lead to increased fuel consumption by 10 to 15% and potentially catalytic converter damage. In summary, the P0153 code indicates a slow response from the upstream oxygen sensor on bank 2, sensor 1. O2 sensors measure the amount of oxygen in exhaust gases. They send voltage signals ranging from 0.1 to 2.9 volts to the engine control module. The ECM uses this data to adjust fuel mixture for optimal combustion. A slow response means the sensor takes longer than 100 milliseconds to switch between rich and lean conditions. Modern smart sensors have microcontrollers for self-diagnosis and Bluetooth monitoring. Several factors can trigger the P0153 code. Common culprits include a contaminated O2 sensor due to oil, coolant, or silicone exposure. Another common cause is damaged wiring harness, corroded or broken wires. Another common cause is exhaust leaks, leaks before the O2 sensor. Another common cause is vacuum leaks, air entering unwanted areas. Another common cause is malfunctioning ECM, engine control module failure. Another common cause is faulty injectors, fuel delivery problems. Another common cause is malfunctioning fuel pressure regulator, incorrect fuel pressure. Less frequent causes involve fuel system issues like faulty injectors or a malfunctioning fuel pressure regulator. Remember to work in a well-ventilated area when diagnosing and repairing to avoid exhaust fumes. Start by using an OBD2 scanner to confirm the P0153 code. This device connects to your vehicle's diagnostic port and reads the trouble codes stored in the engine control module. Next, analyze the freeze frame data to understand the engine conditions when the P0153 code was set. This snapshot captures parameters like engine speed, temperature, and air-fuel ratio at the moment of the fault. Test the sensor's heating circuit to ensure it quickly reaches operating temperature of 300 to 400 degrees Celsius. The heating element helps the sensor respond rapidly to exhaust gas changes. Use an oscilloscope to examine the sensor's waveform for irregularities. A healthy oxygen sensor should show smooth transitions between rich and lean conditions, switching voltage levels rapidly. Always begin with the least invasive fixes, such as checking for loose connections or exhaust leaks before considering sensor replacement. This approach saves time and money. Professional scans are recommended because misdiagnoses can waste up to 30% of repair time. Expert technicians have the tools and experience to accurately identify the root cause. Begin by visually inspecting the O2 sensor and its wiring for any signs of damage or contamination. Next, check for exhaust leaks near the sensor location. If the sensor appears contaminated, try cleaning it. However, replacement is usually recommended. Ensure the wiring harness is securely connected and free from corrosion. In some cases, clearing the diagnostic code may resolve intermittent issues. If these steps don't resolve the issue, sensor replacement is often necessary. When replacing the O2 sensor, use an eco-friendly replacement, as sensors are now often recyclable. Disconnect the negative battery terminal before starting. Locate the Bank 2 Sensor 1 O2 sensor. Disconnect the electrical connector. Use an O2 sensor socket to remove the old sensor. Apply anti-seize compound to the threads of the new sensor. Install it and torque the sensor to the manufacturer's specifications. Reconnect the electrical connector and the negative battery terminal. Clear the P0153 code and test drive the vehicle. To prevent future P0153 codes, regularly inspect your vehicle for exhaust leaks and address them promptly. This helps maintain proper sensor function and prevents contamination. Use high-quality fuel and perform routine engine maintenance to prevent sensor contamination from oil, coolant, or other substances. In humid climates, apply dielectric grease to the O2 sensor connectors to prevent corrosion and ensure reliable electrical connections. Consider using fuel additives that can help clean fuel injectors and prevent carbon buildup, which may contribute to sensor issues. Newer vehicles feature AI-powered diagnostic tools that predict sensor failures, allowing for proactive maintenance and reduced P03 occurrences. The prevalence of P0153 is expected to decline as electric vehicles and hybrids become more common. These vehicles rely less on oxygen sensors since they lack traditional exhaust systems. For ICE vehicles, the trend is towards smart sensors with self-diagnostic capabilities. These sensors integrate microcontrollers for real-time monitoring and can communicate issues directly. Environmental regulations like Euro 7 are pushing for faster sensor response times. These standards require sensors to respond in under 100 milliseconds to meet stricter emission limits. While DIY fixes are rising, expert caution remains for complex wiring issues. Professional diagnostics are still recommended for accurate repairs and to avoid repeat codes. Eventually, as ICE vehicles phase out, P0153 may become obsolete, shifting focus to battery and motor diagnostics. The automotive industry is moving towards electric powertrains,